Hello everyone. In this section 5.3, we're going to talk about using NLP on the actual data set, right? So we can actually go through the entire pipelining using the span data that we used before. So we're visiting this same data set that we had before. So let's get, let's read the data first, right? So we're going to actually use read underbar table because it's a text file. And then there's no header, so we're going to actually do that. So once we read it, so we can actually see there's no header, so df.head, you can actually see it's going to just be spam or ham, and then you have the actual message, but it's going to be like 0 and 1 as the header. Now we can actually assign the columns. It's called spam and message, and then look at the header. It's going to be spam and message. Okay, that's great. So now we are going to cleanse our data first, right? So remember, the stop words we had was, we can actually convert it to a set. So we have a stop word set and then punctuation set, right? So let's look at how it looks like. So stop words set, if we just print it out, a, about, after, again, all these things, right? So let's look at the lengths, right? I think there are about, about 179. And then let's look at, let's look at then punctuation set, right? So punctuation is coming from string, so you have to import string and do string dot punctuation and then put a set around it to convert it to a set. But let's print it out, right? So you can actually see like, explanation, quote, double quote, and then, pound sign, dollar sign, all these things we'll consider as punctuation. So we want to remove these, right, from our original message, right, or text data. So text data is coming from this column, right, MSG. So now let's do, use our lambda function, right? So the way we can do this is df.message, msg.apply, right, and lambda x, and then we can actually project or map this x to something like this, right? So this is actually a very useful thing that you can do is in NLP, in text cleansing, right? I'm gonna actually go over it later, but let's say like what this is doing, right? So what we're saying, this is a list comprehension. What we're saying is that word for word in x.split. So x, remember, is our MSG, right? Because that's how the field that we're using to map to, right? To map from, and then so this, and then in x.split. So x.split is going to give us a list of words, right? Because we're splitting by the space. So if you just do string.split, so let's try something, right? So we have something like this, right? Say we have something like this. Call this a string, string A, right, is equal to this. And then we can actually say, if we do dot split, right, we're going to get something like, let's print it out, right? So you can actually see this will convert the string into a list of words, right? So this is actually a list. So what we're saying is that we want to actually iterate through this list, right? And the word is actually one iterator at a time. So you can say word for word in x.split if word not in stop words, right? So we don't want the word to be in stop words, right? And then and word not in punctuation set, right? So we don't want it to be in punctuation. And then we are putting this so that it's a list, right? It's a list again, right? But then we want to join it back because we don't want this in this format, right? In a list format. We want to actually join it back so that, it's going to be a string, right? So this is how you can actually put it back as a string. So let's look at this, right? So you can see if I do space dot join of this list, right? You can pass a list and you actually get something like this. This is a string, right? So this is a trick that I'm actually using. Space, right? Quote, space, and then dot join to put it back from a list to a string. So now I call this thing as message cleaned, right? Because we remove a bunch of things. And then now let's look at df.head, right? You can actually see there's appended a new column that's called msg.underbar clean, right? It's a cleaner version of this msg without the stop words and without the punctuation. So now let's put it to lower, right? So because you can see they're like uppercase and lowercase, right? All mixed. So we have to standardize. So a way to do this is cleaned dot string and dot lower, right? So and then we can actually overwrite this existing MSG underbar clean. Let's look at it again. You can actually see it's all lowercase now, right? So that's great. Now we can actually start our count vectorizer that I have imported from Scalar, right? So you can actually see in here. A scalar, okay, so yeah, a scalar feature extraction.txt import FDF vectorizer and count vectorizer. So I'm gonna actually start this, right, with this, and call this as count vect, right? And then when I do that, I want to then do count underbar vec dot fit transform. This is a function, right? A class function that you can use. And then what I'm passing, right, is actually this def.msg cleaned. Remember, you want to pass a list of documents or a list of strings, right? So each of this is actually a string, and then you want to pass a list of that. So by doing def.msg underbar clean, you're passing the whole column, but each element is actually a string, right? So that's pretty important. Then I can fit transform it. And let's then take a look at X, right? Well, and then assign this to X. So X is going to be our feature matrix, right? Let's look at X. X is a sparse matrix, right? And then let's look at the shape of that, right? Right. So you can see we have 8,703 columns. This is how many features we have, right? That's a lot, right? So why we have this is, remember, each word, right? Each word now is going to be a column, right? Whenever it sees a new word, it's going to just append this word and create a new column. The column header is going to be the word itself, and then you're going to have the weights, right? Or the counts in that column. So therefore, you can expect, whenever you do this, right? And whenever you're actually dealing with count vectorizers or any vectorizers, you will have lots of fields, columns, right? Like this. So, okay, then our y, what we're trying to predict, again, is a span, right? Ham or spam, and then y is going to be df.span. And then we can actually do train test split, right? Again, I import it from a scalar, dot matrix, and then, dot dot cross validation. And then we can actually split this x, y, right? X is our feature matrix, and y is our target, right? So which is a column, right? And then so x, y, and then I will assign this to x train, x test, y train, y test. And now let's fit this into a logistic regression, right? So again, I import it from a scalar, right? Linear model, and then I will start a linear logistic regression like this, right? Why we use logistic regression is because this is a classification problem. And then I call this LG, and then LG.fit, and then I'm passing X train, Y train, and then LG now is fitted, and then I can actually do predict and passing X test to get Y predict. And then now I want to look at the score on X test and Y test. Right, you can see the score is actually pretty high. It's 98%, right? Now let's look at the confusion matrix. Remember, the confusion matrix I have imported from a scale learn.matrix and then in confusion matrix, right? So this is giving us the split between type 1 and type 2 error. So let's look at this. So we're passing the true, right? So Y test is our true. So let's print it out, right? What's that Y test? Y test is like ham, spam, and then what's like Y predict, right? So let's look at Y predict, right? It's ham, right? So this is what we have predicted, or logistic regression has predicted, right? And then Y test is what we had in our data set, right? So then we can just pass the true value and what we have predicted and look at the confusion matrix. Whatever comes in diagonal, that's where we're predicting it right? Whenever it is ham, we're predicting it right, ham. And then whenever it's spam, we're saying spam. This is type 1 error, this is type 2 error, right? So you can see that 24, there are 24 like occasions where we're actually doing, we're mislabeling spam. But I mean, in terms of the percentage, it's not that bad. We can actually definitely make more enhancement. But this is pretty much it, using the actual data set to and apply NLP, right, to really look at text data analysis and come up with a model like this, right? So hope you enjoyed it. So this is it for section 5. Thank you very much.